In this video, basically we'll be talking about how we can actually use an Arduino to connect an analog input and produce a digital output. For example, if you want to connect a sensor with the Arduino, you want to read the output on a digital LED. So how do you connect and which pins do you use? So as we know that all the sensors such as temperature, pressure, photoresistor, or whatever else we have studied in, they are all analog devices because analog devices are somewhat like this, which are in the wave form, which means the input that they are reading are is in a continuous wave sort of a format. So that is the reason why we use the analog side of the Arduino microcontroller to connect the sensors, and the input that we receive from here is basically transferred to control the LED or a sound or a buzzer or somewhat like that. So any other output device which produces output in a digital format is connected on the this side of the Arduino. So let's see one of these sensors, how we can connect that. If I have a temperature sensor, this one maybe TMP36, the name of the device here. So this one. Now, if you see here, it has three pins. It has power, it has V out, which means this is the pin through which it will be reading the input, and this is the pin through which the output of it would be going to an LED. Okay? And this is the pin which is basically for the ground. So it has three pins, and the meanings are self-explanatory. So let's just quickly connect the power with 3.3 volts, and let's connect the out with any one of the analog pins. It doesn't have to always be A0. You can use any of these analog pins to read the analog input. So here, and then the ground pin can be connected to ground. Now, if I need to produce an output on a LED, I can actually use this LED, and the short leg, which is called the cathode, goes into the ground, and the anode, the longer leg of the LED, can actually go any of the digital, any of them. Doesn't matter which one you're using, you any one. Now, if you go into the code blocks out here, you can actually in the forever circuit, because the sensors would be readings continuously. So what you can do here is you can actually declare a variable for reading and storing the value from the sensor. So here I'm using temperature, so I will just name it as temp, and I can set this temperature variable to not 0, but instead I would actually give it an input, and the input is going to be read the temperature sensor on pin A0. I've connected it on A0. So whatever temperature I'm reading in this unit, degree centigrade, that will be recorded and it will be saved to the temperature variable. And if I really want to see what exactly is it reading before I go on with my program, I can actually use print to serial monitor. And what do I want to print to serial monitor? Definitely not hello world. I want to print the reading from the temperature sensor in this variable. Okay. So if I start the simulation, there is a serial monitor down below here, which is basically like a print console. And you can see that this is reading temperature 24 right now. I will just show you how do you change the values out here. So on my Arduino, um, here, I can actually go and change my temperature reading it higher. Now, if you see, show you, it's 87 degrees Celsius. And if you see in my code, it's now reading 87 degrees Celsius. So that is how you connect it, right? Now, all the other sensors are pretty much the same. Okay. Now, let's say instead of temperature sensor, I want to use a photoresistor, which is for a sensor for reading the light intensity. This is how it looks like. Now, the only difference between the previous sensor and this sensor is that it has two legs, and while the other one had three legs. So this one is terminal one, this is terminal two, and I need another leg maybe to, um, sort of create a leg so that it can be connected to any of the analog pins. Because these two I can use for power and ground, but I need one more terminal to connect it with the analog pins. So I can easily create that if I have a resistor, because I can connect resistor with terminal 2, and this pin, this third, the third connection can be used for reading the analog pin in. So let's just connect it the same way. So terminal 1, I will try and use it with the power to provide some voltage. This one I can use and connect it with the ground to complete the circuit where the current flow happens. And then this one, the third terminal that we created, this can be, second, sorry, here, this can be used with analog. This is how. If I go into the code blocks, I can do the same thing. I am, so here is my code block. um I can use the same temperature value if you, I mean, same variable. Otherwise, I can always just rename the variable and say light, because this is basically reading the light intensity. So I can rename it as light. And I'm saying set the light variable to read, not temperature this time, definitely. I am basically just reading input from analog pin A0 because I want to see what sort of light intensity. So I'm reading the input from the analog pin A0 and I am printing the output to the console. So if I just start simulation here, it will show you the light intensity read. It's 4 right now. So let's just go and check what's 4 here. If I click on the sensor, so the minimum that it is reading is in the 4 value. And since it's a simulation, that's why you see these kind of values. So 4 is like the minimum. And if I start increasing it over here, if I go halfway through it, then if I see my serial monitor, it's reading 369. And if I just go a little bit higher up from here, maybe just towards the very bright light side, then it's going to show me 419. So that way you can actually see, I mean, depending upon what question you have on the examination, you can always see what the value is being read and you can accordingly set your code. So let's say if I want to say that I want to switch on the LED only when the light falls below the halfway range. So what I can do here, I can easily just go to control and I can use an if then block, just like you do it in Python. It's the same thing, Scratch, um, Scratch based coding. So I can say if the light intensity, it is below somewhat like 350 or something, right? So if it is below 350, then the output on pin number 9, number 9 is the one where my LED is connected, pin number 9 to high. And if the light is above 350, that goes in the else. My set pin 9 is going to be, so if you start simulation here, you will see that light intensity is definitely less than 350, and that's the reason why LED is on. Maybe you can connect a resistor out here also so that the LED is safely lighting up. And then when I go above the halfway range, the LED is off right now. This is how you connect the sensors and the output. Just remember that the sensors should be connected on the analog side, and the light, or it's the sound or the buzzer or any other sort of output that you're using should be on the digital. I hope this was useful.